the scalar product or dot product, okay, if given a vector, vector A, A1I plus A2J plus A3K, and vector B, which is B1I plus B2J plus B3K, and theta is the angle between two vectors, then the scalar product of A and B is defined as, okay, vector A dot vector B. Okay, you can write like this. For the component I, component J, component K for vector A, dot component I for vector B, component J, component K. And then for component I times component I, A times A1 times B1 plus A2 times B2 plus A3 times B3. Okay, and then you get something scalar. Okay, that's why we call these two vectors is scalar product and dot product. Dot product because of the dot product between the two vectors multiply. Okay, and then the angle between the two vectors we call theta. To find the theta, we get one formula. That is vector A dot vector B equals modulus A times modulus B cos theta. So from this formula, can be simplified as this formula. So we can say that the angle between the two vectors for vector A and vector B can be simplified as theta equals cos A dot B over modulus A modulus B. Okay, this is very important formula. You need to remember this formula. Vector A dot vector B is equal to modulus vector A modulus vector B cos theta. Okay, try to recall how to find modulus for one vector. Okay, square root of component I squared plus component J squared plus component K squared. Okay, that is, we try to find modulus for vector A. For vector B, okay, square root of component vector I component squared, component J squared plus component K squared. Okay, and then substitute in this formula. Okay, then find theta. Okay, example 1. For example 1, given vector A, vector B, find vector A dot vector B. So vector A dot vector B, you can just write like this, dot. Okay, coordinate component 2, 3, negative 4. Negative 1, 2, negative 1. Okay, for each component I, J, K, you have to multiply 2 times negative 1 plus 3 times 2 plus negative 4 times negative 1. Okay, and negative 2 plus 6 plus 4 and get 8. Okay, see, that one is, this one you get scalar, constant. That's why you call this one is scalar product or dot product. Okay, and then find the angle between the two vectors. To find the angle between the two vectors, we use this formula. A dot B, vector A dot vector B is equal to modulus A modulus vector B cos theta. Then cos theta is equal to vector A dot vector B over modulus vector A modulus vector B. Means that you need to find A dot B, that's from A. And now we need to find modulus vector A and modulus vector B. Then substitute. Okay. Find modulus vector A. Modulus vector A. Okay, square root of 2 squared plus 3 squared plus negative 4 squared. The answer is 29. Okay, and find modulus vector B. Okay, same procedure. Negative 1 squared plus 2 squared plus negative 1 squared. Then, okay, you can use calculator or find that one. That is 6. Okay, settle. Then substitute. A vector A dot vector B is equal to 8. 8 over sec 29 times sec 6. Okay, you may use calculator. And then find the value. Okay, and then find theta. Theta is equal to at cos 8 over sec 29 sec 6, or take this one, substitute, then get 52.66. Okay, settle for the first part. Okay, this is an important step. You need to know, you need to know how to find a scalar product, how to do scalar product, to find modulus of vector, and then substitute to find angle. Okay, settle for that part. For algebraic properties of the scalar product, let vector A, vector B, vector C, vectors M is a scalar. Okay, and as you know that vector A dot vector A is equal to modulus squared Y because of substitute. Okay, using this formula, vector A dot vector B is equal to modulus A modulus vector B cos theta. Okay, then substitute when say that vector A is equal to B. Substitute. Okay, this is A is equal to modulus A. This is changed to A cos 0 degree. Why? Because of vector A is equal to vector A. So theta is equal to 0 degree. Okay, and we can say that vector A dot vector A is equal to vector A modulus vector A times modulus vector A cos theta cos 0 is equal to 1. Okay, then can be simplified as modulus vector A squared. Okay, settle for the first property. The second property is vector A dot vector B is equal to vector B dot vector A. Okay, and if you substitute in this formula, you still get the same one. Okay, modulus vector A times modulus vector B cos theta, or modulus vector B times modulus vector A cos theta. Okay, cool. Okay, and the third one is vector A dot B vector B plus C is equal to vector A dot vector B plus vector A dot vector C. For number 4, M scalar, okay, times vector A dot vector B is equal to, okay, M times vector A dot vector B, or vector A dot vector B times scalar. Okay, between M, okay, here is nothing. Okay, you cannot write cross or dot. Okay, just do in the parentheses. Okay, and A with 0 times vector A is equal to 0. Okay, number 6. Okay, when vector A dot vector B is equal to vector A modulus vector A times modulus vector B, if you can say, it implies that vector is parallel to B in the same direction. Okay, say that this is vector A, vector B. Okay, same direction. So we can say that from using the formula, vector A dot vector B is equal to vector A modulus vector B cos theta. If the same direction, we can say that theta is equal to 0 degree. Okay, cos 0 degree is equal to 1. Okay, and then is equal to 1. It implies that vector A dot vector B is equal to modulus vector A times modulus vector B. Settle for the first one. But, okay, vector A dot vector B equals to negative vector A times negative modulus vector A times modulus vector B. It implies that vector A is parallel to vector B but opposite sign. This is vector A and this is vector B, opposite sign. Theta is equal to 180 degree. Okay, then substitute in this formula. Substitute A dot B is equal to modulus A modulus B cos 180 is equal to negative 1. Negative 1 means that is equal to negative modulus vector A modulus vector B. Okay, done. Okay, for this part. Okay, when you want to show that the two vectors are parallel, you need to show both, either positive or negative, because we don't know the direction of the two vectors. Okay, either parallel in the same direction or opposite direction. Okay, number 7. Okay, number 7. This is quite important property. Vector A dot vector B is equal to 0 shows that vector A is perpendicular to vector B, or vector A is perpendicular to vector B. You can say that theta is equal to 90 degree. Okay, then as usual, substitute in this formula. Okay, this is quite important formula. You need to remember this formula. Okay, please remember this formula. Substitute Ka dot B is equal to modulus vector A B cos 90 degree. Check calculator, cos 90 degree is equal to 0, right? Okay, and then we can say that vector A modulus vector A times modulus vector B times 0 is equal to 0. So, if you want to show the two vectors are perpendicular, you need to show that vector A dot vector B is equal to 0. This is, please remember, this is quite important property.